In this video, we're going to learn how to use the error injection ability of the Exerciser. We have a whole set of tools to allow you to create problems on your link to ensure that everything's working correctly. I want to show you a very simple example, and the error injection stuff can get fairly complicated because you can basically modify anything you want about almost any packet. But we also have some built-in methods to make it fairly simple to modify. So what I want to do, we're going to send data frames when these UFS commands go across the wire. So what I want to do is screw up one of those data frames to see that the device correctly sends a NAC and asks me to retransmit the data frame. So to do that, right before this loop, I'm just going to hit enter a couple times to give me some space. I'm going to use an error injector. The error injectors can be found in the UniPro tools error insertion tools. And you can see all these different tools. Again, these are all laid out in the documentation and the API reference, so you can see what each one of them does. The one that I want to use is the error in TC0CRC. This is the function we're going to call. So the error in TC0CRC takes several parameters, and I have to tell it what I want to do to the actual data frame in order to screw it up. So the first thing I need to know is what CRC action do I want to take. So in this case, I want to take the data frame CRC action of bad CRC. So it will actually change the CRC. The other thing I need to know is the payload byte length. Now this is important when you're trying to do a CRC error because the CRC comes after the payload. So I have to know how large a payload I'm expecting so that I know where to find the actual CRC data. So because we just ran this test, if I flip back to this, I can look at this query request read attribute. And I'm going to drag bookmark B1 down to this query request attribute, and we'll go to the UniPro packet list, and we'll go to B1. And you'll see here's that data frame that is going to be sent when I do that read attribute. Expand this out a little bit. You'll see that this has the end of message set, and here is the payload. So the payload goes from byte 4 out to byte 34. That's a payload length of 32 bytes. So I'm going to go ahead and set 32 as my payload length in my test. So flip back to the test, payload length 32. And finally, it needs to know the direction. Do I want the exerciser to mess up this data frame as it's leaving the exerciser or as it's coming back in? And which direction you set will often depend upon what you're trying to accomplish. And in this case, I'm trying to mess up a data frame that I'm sending. So I want to change this data frame prior to it going out on the line. So we'll type error injection direction dot tx for send. Okay, so now as the data frame goes out on the line, we will mess up the CRC. Now the good news is the stack behind this has no idea that the data frame got messed up. So when the device NACs, the stack says, oh, okay, sorry, and it resends a perfectly formatted data frame. So it still knows about the good frame. We screwed it up prior to it getting on the wire, but after the stack sent it. So the stack should just naturally resend the frame, and everything should correct itself. So there I've now set this up. This will cause an error in the next TC0 to have a bad CRC. So hopefully this should only happen for this read attribute data frame, and the rest of them should send just fine. So I'll save this test. I will build it, and we'll go back to the application software. Now we'll go ahead and start the analyzer, start the stem, and stop. Now if we look at the UFS packet list, go down to the bottom, everything here should basically look the same. There's our read, there's our write, there's our read, and it happens all the way down just like we had before. We do the read, write, read 3 times. So nothing looks changed in the UFS side, as we would expect it not to. But I'll go ahead and put the B1 on this query request read attribute, and we'll switch over to the UniPro packet list, and we'll go to B1. and you'll see we have a data frame perfectly formatted, everything's fine. But if I were to look in my traffic overview and go to the data frame just previous to this one, and you'll see this has a frame sequence number of 18. I'll go just previous. Here we have a data frame with a CRC error. So this was the result of our error injector. So this data frame, the CRC was manipulated. There's our sequence number of 18. You can see our CRC is 7C8D. So then you'll see what happens. The device correctly NACs. We go through and resend that data frame, this time sequence number 18, with a correct CRC. So that was the result of our error injector, and we can see that we did in fact get a bad data frame, the device correctly NAC'd it, and we resent it. So error injectors are really useful for causing error conditions in your trace to make sure that your device is responding correctly to those errored situations. We've only touched on the surface of the power of what you can do with the Stimulus tools. So I encourage you to go read the Stimulus User's Guide and also spend a little bit of time in that Stimulus API reference. And again, those can be found on the Test Editor menu, Help. You have your UniPro Stimulus Editor Manual. The UFS Stimulus Editor Manual will be up shortly. And then you have the Stimulus Editor API documentation, which will really tell you all the different methods and properties that you can run in both your UniPro and your UFS tool sets.